you all to the second day of GYAN course titled Thermochemical Conversion of Biomass Waste to Bioenergy and Value-Added Products. Hearty welcome to both offline participants and online participants as well. Now I request Professor Ong to continue with the session.
Can you hear me? Okay. Welcome back to the second day of our courses. So far, any feedback, any suggestions that you want to give before I start the lecture for today? Still can follow, everyone. Still can follow. So have enough sleep. Yeah, okay. So without any further ado, I will start the lecture for today. So before I start the topic, so I would like to share these figures for you to think, because every time before I start my lectures, I like to throw out some problem that we don't have one definite solution yet, solution. So today's topic is about the energy and water. Why energy and water? So these two resources are very essential for the human beings. Because everyone we need what? Energy. Need energy for what? For education. Without energy, no education, no lighting system, nothing. So for education. Secondly, for what? Healthcare system. Healthcare system. Without the health, we cannot do anything. And after that is for your living, for your entertainment, for everything. And all our living life, we need the energy. And also the water is also very important. Water is more important for what? For plantations, the food, the sort of the food, the drinking water. And also we need water to produce what? Energy. For the cooling plant, correct or not? For the cooling plant. At the same time, we need the energy to produce the clean water. But these two resources are limiting each another. So how we going to have the sustainable water and sustainable energy? So any solution for that? Because you see, we need both. We need both. At the same time we need both. But they are limiting each another. Limiting each another means what? We need the energy to produce the water, and we need the water to produce the energy. And both resources are what? Limited. Then sometimes not sustainable, correct or not? Not sustainable. Some of the locations lack of water, lack of electricity, correct or not? So how we going to make sure we have the sustainable clean water and sustainable green energy? That is the thing that we all need to think, because all of you are what? Scientists. Some of you are scientists, scholars, research scholars, engineers, correct or not? So for us to think how we going to these two resources, since these two resources are running short anywhere, because the demand of these two resources are definitely will be increasing day by day, and due to what? The population, the increasing of our living lifestyle as well, right now. Yep, that's the thing. So any feedback, any comments on this? So how we going to have the sustainable green water, sustainable green energies? It's one of the way. It's one of the way. It's one of the way. Correct. Because for us at this generation, we are so fortunate because we don't need to think these two resources. These two are automatically on switch. We have electricity. We didn't think how it's come from. Correct not? Tap water, open the tap water, we have the clean water already, right now. We never think how it's come from, how it's come from these two present resources. And sometimes we let the electricity just switch on, just wasted this only. Similar for the water, that's the thing. We will think of how precious these two resources. So before I start the topic, I already categorized what will be covered in these courses. Again, first topic is about the biofuel and bioenergy, which I already started on the liquid fuels, which is what is the biodiesel and what is the bioethanol. Biodiesel and bioethanol, the focus more on the liquid fuels, so that you are more clear about that. And also we use the F1 technologies. F1 technology, that means the technology that we use for our study is microwave, ultrasound. We use the catalytic reaction and so on and so forth. At the same time, we in our group we further upgrade the liquid fuel into the biojet fuel or the sustainable aviation fuel. This one we started in 2018. We started to start a study the potentials of converting this biomass waste into the what? Into the biojet fuel. Of course, we are facing some problem. Some of the property I cannot fulfill. Then later on I will discuss in details. So the process we are looking for is the single step. There are many other technologies can be converted into the biojet fuel, but what we are looking for is the single step. One step directly, one pot, one step to convert into the biojet fuels. Of course, we have covered the thermochemical conversion process, which my main focus, personally my main focus is the pyrolysis and torrefaction. So I believe most of you heard about the pyrolysis, know about the pyrolysis. So any one of you don't know what is pyrolysis? It's one of the very common thermochemical conversion process. Then the torrefaction. So how many of you know what is the torrefaction? Torrefaction. Sorry? What temperature? Lower temperature. Yes, it's lower temperature. Yes, below 300. Yes, correct. So torrefaction is relatively we can say the mild pyrolysis with lower temperature. Why? Because why? The people some don't want to use the thermochemical, the pyrolysis process or even the gasification process because the temperature is relatively high. Relatively high, that means easily more than 500 degrees C. The minimum is 500 degrees C for the pyrolysis because it's one of the very energy consumption process. And while the product we get maybe sometimes unable to recover back whatever the energy input, I mean the imbalance between the output and input. So that's why we have the torrefaction process, which is one of the relatively mild pyrolysis. I can say mild pyrolysis because the reaction temperatures can be between 150, 60 to 300 degrees C. Of course, we have the hydrothermal. I guess all of you know what is hydrothermal. Hydrothermal, that means hydro with water, involved with the water. Thermal. Hydrothermal, that means steam, heating, heating. So hydrothermal is must be deal with some pressure because if we have the water in one of the closed systems, the pressure automatically will be increased. So for the hydrothermal, normally in the industry, we are using the relatively low temperature. Why? Because if we use the high temperature, we can use the high temperature, but your reactor, the result of your reactors must be enough to stand for the high pressure because when you heat things, the pressure automatically will be increased. So how are you going to reduce that pressure? So yeah, because if high pressure, the idea is from the scientific point of view, the idea is high temperature, high pressure is very good for any reaction. Any reaction is very good. You will get a very pure substance or pure products, without adding any chemicals or any solvents into your reactions. But due to the very high initial cost, so we need to take the balance between high initial cost. Why high initial cost? Because the high temperatures you need the special design reactor that can stand that high pressure. That's the thing. Then secondly, during the maintenance also very relatively high. If you deal with the high temperature and high pressure, that's the thing. The industry is less. The third one is what? Safety problem. Safety problem. So anything happens with the high temperature, high pressure, will be cause a very serious safety issue. So hydrothermal and also wet torrefaction. Similarly, when we see the word torrefaction, it means relatively low temperature. Maybe we can say the low temperatures low temperature hydrothermal, which normally is working on the around below 200 degrees C, is around 160 and 170 because the pressure is relatively low at that temperature. If we taking water as a medium, if it reacts at around 160 to 170, the pressure might be 10 bar only. 10 bar, which is 10 times of the atmosphere pressure, which is relatively low. So normally, the current industry, they using these temperature and pressures for their hydrothermal reactions. Of course, we also discuss the co-pyrolysis, co-corrections, and also the co-products. Co-products in this one, I think I already discussed yesterday. For any hydrothermal reaction, or not necessarily hydrothermal, for any reactions, you have your main products that you want to focus on, but at the same time the byproduct will produce as well. See, better depend on your focus on the product, and also your process, and also what is your main focus of the product. See whether you want to recover the byproduct or not. Sometimes you not necessary to recover the byproduct, because the byproduct might be helping in the main product as well. Or sometimes your byproduct will be emitting your main product. For example, the byproduct will reduce maybe the energy content, for example, or will we have the negative effects on your combustion. So we might think on to recover back, recover the byproduct. Or sometimes we found that your raw material or your feedstock has a certain compound. We don't know, you got certain compound. Maybe that compound will we have the negative impact on the process, sometimes that we not aware about that. So maybe before we start that reaction, the hydrothermal reaction or any reaction, we can maybe recover or separate that small amount of the we cannot say the impurities, because it's already together with your main product, with your biomass. Maybe you can recover back for others value added product or others purpose, and before we proceed with the process. So that's why it's very important to see what is the physiochemical properties or the detailed characteristics of your products, of your raw material, not only product, the raw materials. We start the reaction. You can start the reaction first or whatever, process first, but you see, after we remove this byproduct, what is the effect on your final product? That's the thing. Then after that, the first one is we go focus on the liquid fuel, liquid product. Then we also will focus on the solid product, which is the biochar. So the solid product, in our team, we use the solid product as the solid fuel. Solid fuel is the characteristic value or the energy content for the solid product is high, so we can directly use as the solid fuel. And or we also exploring the potentials of the application of the solid product, which is can be used as the biofertilizer or bioabsorbent. Yeah. So you can see further studies. And lastly, normally after we conduct the whole process of the industry process, so we like to have the life cycle analysis. See what is the emission balance. So whether you have produced more emissions throughout the process or not, or you can have the net zero emissions, or you have the negative emissions. Sometimes you can have the negative emissions, and followed by the techno-economic analysis. See what is the economical feasibility and what is the payback period by taking maybe the project lifetime of maybe 20 years. So what is the payback period? This is what we also covered in our study in our lab. So this one is we work toward the circular economy, because previously what we conduct only one line is from the raw material, throughout the process, and finally we get the product. maybe we study the life cycle analysis of technology for this process only, for this individual process only. But we can see the overall circular economy, how each byproduct of each process can have maybe some waste. How can we recover the waste to convert it into the other type of the value-added product during the process. So later I will show you how we're going to make it circular. What is meant by the circular? Circular is not only recycling what remaining product or convert the remaining product what for the overall process. Yeah, for the overall process. So this is this few slides. I will show you the overall of our studies. First one, this one I think I will show you. This is the basically more on the biofuel. This is our lab. This is our lab. So basically, what we do is we convert the biomass waste, secondary-ration. These all are the waste. Biomass waste. Convert it into the biofuel. Biofuel, which we focus more on the biodiesel, followed by the bioethanol. We study the parameter studies, the qualities and also the yields of the product. After we convert it, we do the optimization. What is the optimal process for the lab scale and for the pilot scale? Because sometimes we want to upscale, the parameter might be different, might be changed, and the overall life cycle analysis or life cycle cost might be changed as well. If from a lab scale and for the pilot scale. Because for the lab scale, what we want to do is to proof of concept. Oh, this technology is work. Then after that we need to think how to upscale, how to upscale it. So first thing is about the liquid fuel, liquid fuel from the non-edible oil. Then after that, we further upgrade the liquid fuels into the biojet fuel. This one we conduct these studies before the COVID. Before the COVID, people travel around the world, right? The air transport is increasing year by year, and also the emissions from the air transport is also increasing. So you see in 2019, they plan to implement 0.1% of the sustainable aviation fuel. Sustainable aviation fuel, that is what is the totally green fuel. Not using the ZA1. ZA1 is a fossil aviation fuel. So it's 0.1%. But now they want to implement at least I don't know how many percent. If I'm mistaken, it's 5% before the aeroplane can be taken off. So that's why. So this one we started the study in 2018. What we do? Selection of the feedstock. We want to select what is the suitable raw material to be converted into the biojet fuel. Because if you know about the sustainable fuel, the carbon numbers shouldn't be more than C16, because most of the biomass feedstock they have the carbon change of between C12 to C20, even up to C34. So we need to select the feedstock that have the shorter carbon change or carbon numbers. That's the thing that we want to study. So we need to study the suitable feedstock. And also one thing is very important. You see the freezing point. For the normal biofuel, the freezing point is around the maximum also -20. But for the ZA1 fuel, they require up to -40. That is another property that we need to consider. Then the other is almost similar. If we are able to get a short carbon change, the density automatically will be reduced. Because for the normal biofuel, actually for the sustainable aviation fuel is almost similar with the green biodiesel, but the property is different. The fuel you look by the eyes is almost the same. but the properties is totally different. So that's why the process might be different to crack the carbon chain into the short-term carbon chain. The process must be able to do so. That's the thing. And also the freezing point. While we need to maintain the heating value. So this is our target. Yeah.
The price is still the same. The price of jet fuel and biodiesel.
No. Jet fuel is slightly higher.
Just a little bit, 5%.
I think it is more than that.
In India, it's just like less than 5%.
Oh, India is the same.
Yeah, almost the same.
In India it's almost that, but in many countries for the sustainable aviation fuel it's much more higher price. Because with the support of the government or whatever, so if this is sustainable aviation fuel, they can get the subsidies for at this moment. Because why? Subsidy is important. You know what? At the very beginning, to encourage the factory to produce the sustainable fuel. Because with they have all the instrument and equipment, then they can further reduce the overall production price. If not, no one want to start.
So regular aviation fuel and sustainable aviation fuel, does it have any price difference?
Yes. They mean the jet airline fuel. With the SAV, yes, they have some difference. They have some different. At least for the EU, they are some different. So that's why many developing countries they are exporting their SAF to the European. Because why? They are very support this policy, so that's why their price much more higher at this moment. Because why? They already regulated, if not mistaken, I'm not sure how many percent already, if not mistaken, 5% by this year before their airplane can be taken off. So that's why no matter what is the cost they have to buy at this moment. You can just Google yourself. Yeah. So that's the thing. Yeah. So we need to see what is a suitable feedstock. Then currently, we found that the waste used cooking oil or waste cooking oil might be suitable. So currently in the industry, many of them is converting the waste cooking oil into the sustainable aviation fuel. Yep. So we already have technologies. So how, like yesterday, what I discussed, how we going to make the overall process price lower. That's the thing that we need to think of. Then selection of the catalyst, because the sustainable aviation is different, the process is different. It needs to use the catalyst to break out the carbon chain, the long carbon chain. Then selection of the reacting temperatures, like your process temperatures and amount of the catalyst that you want to use. And finally, selection of the effective procedure. There are many technology and many procedures. And also we need to study what is the percentage of the selectivities. Many studies or researchers they think that they are able to produce the sustainable aviation fuel or jet A1 fuel or the green diesel. Green diesel also one of the name of the sustainable aviation fuel. But they only focus on the what? Mono compound. Mono compound is what? They select a certain mono compound. Of course, they can produce a very pure sustainable aviation fuel. But in the real life industry, it is impossible, correct or not? So how we going to convert this biomass into the sustainable fuel? Because our goal is we are not using the mono compound. We are using the biomass rate. But of course, currently the result is not desirable yet. But with the missing, I mean, if missing, I didn't show you the result because that one I will show you in detail because today is just a brief instructions on all the processes I will cover. So with the mix with the certain percent, I don't know between 5 to 10%. I don't know how many percent already. Then you can fulfill the standard with a certain percent.
Sir, can you just elaborate more on carbon number? Is it an important parameter only for jet fuel?
It is very important for the jet fuel. Jet fuel. Why? Few reasons. you look at the density. The densities for the ZL1 fuel is relatively low compared to the normal biodiesel or your green diesel or your green fuel or whatever you want to name it, is relatively low. Why relatively low? Why we need low? Because we want to have the more energy content per liter or per meter cube of the energy storage. High energy storage content. So that's why.
Should be a lighter fuel.
Correct, lighter fuel. Yes, we want to maintain the lighter fuel because we want to take together with aeroplane. We want the lighter fuel. Lighter fuel while maintaining with the what? The heating value. So that we can store more energy content per meter cube. Per meter cube. So that's why with this we need the low carbon change number. Yeah, that's the thing.
So for base cooking oil is more because it's been used
Correct.
more and more.
Ah.
The chemical composition changes.
Yes, correct.
It becomes very heavier.
No, because it more and more, some carbon is cracking to be the small carbon change. But if we are content a lot of the impurities, it's true. Yeah.
So then the processing is
Correct. We need to filter out this impurity first. A lot of the impurities, Correct.
but still they are using that for jet fuel.
Still, currently in the industry, a lot are using the used cooking oil. Yes, waste cooking oil, the used cooking oil. Yes, correct. Now at this moment, so then the next question is how you going to correct the sufficient amount of the used cooking oil so that it fulfill the economical feasibility. Correct? Now we want the corrections, maybe the cost of the corrections or the energy for the corrections is more than that. That one you have to think how to make it feasible because for the different region, different location, they have the different way for you to correct. Then think of the way and how to make it possible. That is your business secret of business plan. That's the thing. Because as I told you yesterday, many things the technology is already there. Then how you find the solution to solve it or how you package it. Okay. I give you another example. Currently, everyone say want to do the AI automation control system, correct or not? But all the technology already there. Then how you going to take out the suitable component, make it and package it become one product? For example, laptop computers. Laptop or computer. Okay, we take the laptop. You see this one, the chip. If we already have the motherboard chipset, we have a processor. Then someone, the first person that can combine this one together become one product. Then he can success. Then another person, maybe I combine, it becomes smaller, more user friendly. That's the thing. Technology like that. That one is more on the industry design, process design person. So this is what I learned in Taiwan because they are very good in the industry process design. How to take the component part to redesign become one of the brand new product that can bring the convenience to the user. This is how you can earn the money. Chip and component, how to combine together. That's the thing. This is what. So how to correct the what? This one you have to think the business plan because it's totally different for any reason. Even within the India, maybe the West India and North India is totally different way for you to correct. Maybe sometimes, maybe might be the same, might be the difference. Yeah, might have the totally different business plan. That's the thing. So you have to think the technology already there because we as scientists or engineers. So we discover the process and technology. Then how we going to close the last one now to make it commercialized. That is the thing. To make it different. This is what you all need to think. So for those master and PhD scholar, of course, the main task is to discover the new knowledge, the new technology, to make sure this technology is feasible, to discover something new. Yes, of course. Then after you discover, then you think of how we're going to convert it into your commercial plans. there are many success stories. There are many success stories I can share with you some. One of my friends, he is the materials engineer. During his master, he recovered one way to discover one way to extract the heavy metals from waste, from one type of waste, He recover one of the way to what extract up the heavy metals. The waste totally no value. People want to throw away. Want to get rid of it, but he found a way. But this is the new recovery. If he cannot turn into the business plan, that is the new discovery. Is very good. It's very good as well. But how we going to turn? Then he know. Oh, he need to think of the way. How can I correct this waste with the minimum cost? Then how I can? Yeah, he has a technique already. Then how he can make this commercial process become a commercial process to turn into commercial process. Then to sell the what? Sell the heavy metal. The heavy metal is the what? Removal techniques. Yeah, that's the thing. This how we going to learn. So sometimes you recover because we recover for those working on the maybe wastewater recovery. You want to remove the heavy metal, remove the whatever. Then some of the compound. If you find a compound is maybe the percentage high. Percentage high means high. Here is more than 10%. More than 10%, you can make it profit already. But provided that compound that you recover is useful for the certain industry process. That's the thing. It's value for the certain industry process. That's the thing. This another way. There are many. The small things you can do. 20 year back, the waste tire, the wheel, the waste tire. You see, if you have the car or motorcycles or anything, every 2 years, you want to change your wheel, right? Car has 4 wheels, motorcycle has 2 wheels. People just throw, right enough. And sometimes the tire shop ask you, can pay you maybe $1, $2. You help me to throw the tire. Then that one is possible to convert it into the bio oil, and also the biochar. That one, that is the thing. How to solve the people problem, and how to develop one product that can bring the convenience to the community. Convenience to the community. That's the thing. Like maybe 60, 70 years ago, you have the KFC, McDonald's. Why? Because they make the food fast, efficient for the user. Correct not? Food, everyone can cook, right? During the time, then people not really tend to buy the food outside, but they make it possible because make it convenient. Then the quality can control it. Every piece of the chicken is fried, same taste, right not? That's the thing. So that's the thing. So this one, go back to our topic, aeration fuels. So this is what we do. So here we propose two process. Two process is almost similar. One is without pressure. One is with pressure. With the pressures. We use the nitrogen gas. The process we are using is the oxygenation to remove the OH, then replace with the H. Then we select the feedstock, select the catalyst. Then in that study, we just use the commercial catalyst. So if you are able to design one catalyst that's useful for the process, then it might be better. And what is the temperature? Then after that, of course, before we can use, we must compare with the ISTM standard, make it possible. So this is a ZL1 fuel or 2%.
What is the function of the catalyst?
The function of the catalyst for those chemical, they can answer because the catalyst able to enhance the one of the very common definition of the catalyst is enhance the overall process, chemical process, enhance that means make it more efficient. Or secondly, make it high yield, so that it can push the certain process towards that direction. For example, for any process, any thermochemical process or any chemical process, during one process, maybe there are 3 or 4 or 5 process might be happen concurrently. So, but you want the certain process only, maybe process A only. With the help of the catalyst, we can enhance the process A, so we can reduce the reaction for the process B and C. That is the catalyst, the function of catalyst. Yeah, in general, yeah, that's the thing. So we must design one catalyst can push your process towards the product that you want. Yes.
It will also increase the rate of reactions.
Increase the overall rate, increase the yield, or sometimes increase the purities of your product. Quality also, purity, quality of your product. So it really depends. Each process has the different catalyst. Of course, we have the certain common catalyst. For example, in our chemical process, the chloride is one of the very, very, very common catalyst in most of the process. Chloride. Then with the chloride, then you can put in embedded with the others, maybe heavy metal, whatever, to boost your certain process that you want. That's the thing. Chloride is one of the very common catalysts. I use it in the industry nowadays. Yeah. Or calcium oxide also. Yeah.
So in this particular process, what's the catalyst that's being used?
Sorry?
In this particular deoxygenation process, what's the catalyst that's being used?
Which catalyst is used in this?
In this process, we try most of the common commercial catalysts without any modification, because this is our primary study. So we found that I can't remember already. That one I need to go back to my side. This one is connected. So
Sir, zeolite is generally used as a catalyst. Zeolite.
chloride, yes. Chloride is a common use catalyst for the some deoxygenation process or some other greenfield production process. Chloride is a very common, but normally they embedded the chloride with one of the heavy metals. For heavy metal, yeah, not using the, yeah, of course. This one I mentioned, the chloride is without the activations. Yeah, one thing is you need to activate. This one is all the chemical things. You need to activate your catalyst first before it can be used. Activate, the activate meaning what? You make the catalyst suitable for that process. Before activation. We make catalyst. Yes.
In the image of the biojet fuel, the colors are different. How different from each other? The black one and towards the left.
Okay. Sometimes, for me, I didn't study in details what is the color difference. But sometimes the color might be different, but the properties are similar because it depends on the feedstock, the raw material. Sometimes it's depends on the raw material only. Then sometimes it's the black one. Of course, obviously they have some impurities already. Maybe sometimes it doesn't affect the overall product. Sometimes it's yes, sometimes it's not. Yeah, color is, for me, it's not really have the much effect. We need to see the overall properties, the ASA properties. Yeah. Basically, mainly, I can tell you is the color is basically based on the raw materials.
Is it because of difference in the densities of all the four?
Density, I think, does not have much effect on the colors. Sulfur, for the biofuel, the sulfur content almost zero. No sulfur content. So that's why that is the benefit of using the biofuel. Biofuel almost don't have the sulfur, but they have the N. The nitrogen, nitrate can be called the nitrate, nitrogen, because these are organic products. Organic product, we have the nitrogen compound, N compound. For all the biomass, most of the biomass, we have few compounds, few very common compounds. C, carbon, hydrogen, N, and O. This one. So that's why the biofuel sometimes will produce more NOx, NOx. So because why? Initially the biomass, biomass has the nitrogen compound. That is the thing. Nitrogen. Sulfur don't have. Only the fossil have the sulfur. Yeah. Fossil.
Sometimes like when they have to sell it, the customer sometimes they try to look at related that the lighter color is more efficient fuel.
Correct,
So
correct.
this decolorization
Correct.
is one something that
Correct.
you look at.
Yes, correct. Yes.
Even though the properties are same,
Correct.
still they just like buy. Usually they want.
Correct, correct. True also. Because true also. So before the industry process we need to do the pre-treatment. Yeah, pre-treatment. Sometimes we need the pre-treatment. Pre-treatment like the degumming process or whatever process that necessary. Yes, you are right. Yeah, right. Make the colors better. Yes. Yeah, the way. Yes, the way as well. Yes. Correct.
The marketing thing.
Yeah, correct. Correct. And sometimes some of the bio oil is very hard to burn. So we have to wait to increase the ignition point to have the lower ignition point. Sometimes the ignition point is very high. Ignition point is high, that means we need a higher temperature so that it can be burned. That's the thing. Yes, correct. Yeah. Because sometimes for the industry process because the feedstock maybe they have the slightly different properties. The product may be different. Slightly, especially we are using the waste as a material. That is the thing. Yeah. We are using the waste as a material. So yeah, still we are using the filter of the feedstock. We still found that waste cooking oil and the palm is a suitable candidate for the